So I will talk about usability analysis system for e-learning offering tools. My name is Manuel Freire. I'm with the University of Madrid for the EUCM group. I started working on adaptive hypermedia, on adaptation here at the Autonomous University, and I presented my thesis in this very hall. Up there you can see very small screenshots of the systems that I used then. It was a hypermedia system called Tango, and I made a graphically network-based authoring tool for this hypermedia system. Later on, more recently, I've worked in digital visualization, and those are two of the systems that I worked on. And now I'm back to adaptation and authoring with a very similar problem domain. I am working now with EUCM on a game authoring, and games are very similar to hypermedia in the sense that there are many possible actions, there are many possible ways to play through the game, and the author has to think of these possible ways to traverse the game in advance, leading to what is effectively a network. One of the members of the e-adventure platform is here with us, Eugenio. Say hello. Eugenio has been working on building a network-based authoring tool for this system. And the problem about having very rich contents is that somebody has to make them, and that later on people have to be able to reuse them for slightly different tasks. Authoring is difficult. First, you have to have somebody that has the idea that he wants to build into content, and then you need to make this idea become reality as straightforward as possible. There's been recent work on creativity support tools. The main idea is to give the greatest freedom possible, this low threshold, high ceiling, wide walls idea, while keeping things very, very simple to avoid exposing the user to unnecessary complexity. It's also very important to evaluate the authoring tools that you're creating. Unless you strive to make better and better authoring tools, it will be difficult to get users to create content. So this is the problem that we're trying to solve. The specific instance of the problem is we have just started transitioning from a traditional authoring tool to the network-based authoring tool. In the traditional authoring tool, you have to build each part of the game safe format separately. You need to build a scenario, a list of scenarios, then you need to build a list of persons, then you need to build a list of conversations, then you need to build a list of items, then you need to connect things carefully one to another, and finally that gives you a game that you can play. In the new tool that is down here, the idea is that you build a map of the states through which the main character goes. So at the beginning he is in that room, and that room he can take that door to that other room, and there he can talk to this person, and essentially you have a snapshot of everything that the person is doing, that the main character is doing. So we think that this is a better fit to having a good idea and trying to plan it on paper as soon as possible. So we want to evaluate this tool, and this tool subdivides the authoring process into only 3 parts. That's down from about 10 different categories in the previous tool. Of these parts, we have actors in the world that are relatively fixed. You only decide on a cast of characters once, and you don't need to think of too many scenarios. You mostly have that in your head. And the interesting thing is the story flow. This screen that we're seeing here, this third element here, that's where all the magic happens. So we're going to concentrate on the story flow. And we are trying to see if the interface B is better than interface A. Interface A is a modal interface, where if you want to add a new conversation, you have to click on the conversation button, and then you have to say from where the conversation goes to where. So you have to think in terms of a operand, operator, operator. And the second is, we think, an easier approach, where when you want to change something, you click on it, and then a textual menu comes up, and you're offered the choice, the radio menu, a radio context-aware menu, that tells you exactly what you can do here. You can always remove things, that's over here, and then you can add a transition, you can add actions or comments, you can edit things if that's something that you can edit, and so on. And to decide between these two interfaces, we did a study, and we used A/B testing. A/B testing is the idea that you give a large pool of people different versions of the tool, and you compare what people do with the new version with what people do with the old version. But the people are not necessarily aware that they're testing something. You just you tell them to go to this place to get the tool, and the tool that they're getting depends on where they're seated. And this is very nice for the web because you can have 10,000 users, and you can suddenly have 5,000 testers using the A interface and 5,000 testers using the B interface, and they don't know what they're doing. And the important part is that you need to be able to measure outcomes. You need to be able to know who is doing better. And if we're selling things online, we can see if the A interface sold more things than the B interface. So that's easy. If we're testing the offering, that's difficult. We have no way of knowing if an offer is doing better than another. And we can check that they're doing things that are correct, and that if we gave them a task, their task is complete. But beyond that, it is very difficult to measure quality. So what we do is we do not measure quality, we ask them to say what they think is better. So I should not use the drawing board because the camera will not see me. But okay, do we have anything to draw with? Yes. So, independently of what these three things are, if I am asked to compare them and to rank them from 1 to 10, then maybe I will give this one 4 stars, I will give this one 5 stars, and I will give this one 3 stars. This means I like this one better. And you do not need to ask the person who is doing this for a very complex definition of what he thinks is better. The only important thing is that he is internally consistent. In his criteria, he knows that he likes this better than that. So we want to use these ratings as an outcome. So we ask end users to rate M results and maps of storyboards. And no user rates the same user twice, nor is rated twice by the same user. So you cannot rate yourself. And how do we process this? How do we get some numbers out of this? Well, the null hypothesis is that if this interface is interface B, and this is interface A, The number among everybody of A interfaces rated better than B interfaces should be a random coin toss if there is no difference between them. Here's an example. That's one person rating things, and 3 of the interfaces that he's rating are A interfaces and 2 are B interfaces. There's only one case where B interface is rated better than A interface, and there's 4 cases where A is rated better than B. So if we do this a lot of times, we would expect that if there's no difference, the number will be the same. In our experiment, we had 20 users that had never used Weave before. They had a 5-minute tutorial to learn how to use it. And we gave them a task, implement Little Red Riding Hood as a game inside the adventure. They had 1 hour of time, and the outcome is 70 total A versus B comparisons. And 40 of them, B was better than A. So we test this against one-sided nominal distribution, and we not get the null hypothesis. 40 out of 70 could be lucky, could be this lucky. It's not outside the 95% confidence interval. We simulated this. We built simulated users, and we fed the simulated users with a preference, with an artificial preference down here. This is no difference. They rate both interfaces equally. This is they give 1 more star to the A interface. So they give 2 more stars on average to the B interface, and so on and so forth. And we tested to see what p-values we got. We want to know if this method of testing works. And we concluded that with 20 users and 4 evaluations each, it is not very good. Because here we have things that we would consider significant, but we know that there's absolutely no difference. So this method is failing. So what can we do? We can either increase the number of users, or we can increase the ratings that each user has to do. So if we increase the ratings, suddenly we have no false positives. We've just doubled the number of ratings. And we have a lot less false negatives. And essentially, by the time we reach 1.5 average, it will work every time. Compare with here, we need to reach 2.5 average stars to find a difference with full confidence. The other thing that we can do is increase the number of users. We can ask more people with the same number of questions. If we double the number of users, we are a bit better, but we still have noise down here. If we increment the number of users up to 100, we're basically almost as effective as increasing the number of ratings. So now that we know what we should have done, not what we actually did, at least we studied the problem and we gained some insights. This is the version of the system. We have monitoring going on. We have instrumented our user interface so that it sends data constantly to a server. In particular, it sends screen captures, and we keep the last screen capture to do this rating thing with. And then the question is, how do we analyze this? Besides doing statistics, well, we built this tool over here. And this tool has a main detail pane where if you select a particular screenshot, you can look at it in full detail. And then for each user that you select on this side, you will see a time-lapse sequence of the states of what he was working on a long time. Interspersed over here, you see textual records that indicate what actions he did to go from one to the next. And this is the kind of things that we see. Here on top, we see the pattern of a user gets stuck and does nothing for 2 minutes. You can see that this remains the same and there are no actions. Here you can see a user that is furiously clicking around and building things very, very fast. And if you click on this, you can see actually what he's building each moment and exactly what things he is furiously doing. And here we have a very special user that decided that he wanted to have everything in a rectangular grid. That was a user who would not like to meet on a dark street at night. You're also seeing here the difference between two particular images. It's showing what has changed between one another. So for user interface evaluation, this allows us to see quickly what a particular user did. You just need to look at the timeline. You don't need to watch the whole video. We have videos, by the way, but my computer is not working right, so I can't show them. I'll be happy to send them to anybody. And we can also quickly check what's the difference between this and that. And we are missing a couple of features that we would like to have. We would like to have a time zoom, where we can see more frames or less frames. And what we would do with some filtering and sorting. And for the next experiment, we're going to try to get more fine-grained data, especially to get a lot more ratings per user, because we saw that statistically this makes a difference. And we want to test new automated layout. So what have we learned here? We have just demonstrated an A/B testing methodology that works without any need for an objective outcome. We have a reusable server that can be used for any gathering task, and we will be happy to share with anybody who wants to use it. And we also have a reusable client that is capable of building these time-lapse displays of the data that have been gathered with the server. And the only thing that it requires is a little bit of specific handling to parse textual log entries to be able to build very small thumbnails from them. So this is everything. Thank you very much. So, questions or comments? Well, that was quick indeed. I think we're way under half an hour.
Yes. Can you explain about the data, the evaluation of the data on the okay?
Yes.
You said that for the first picture, you said that okay, we have almost the same results for the case A and case B. Okay? And then you conclude that okay, it's wrong.
No, the method is correct. Okay,
I missed something. I want to know more.
Okay, let's go back, and when I lose the slide, you just tell me. Here?
No. Yeah.
Okay. So the problem here is that we've reached a p-value, but we do not know if our methodology is very good at creating p-values that you can trust. So assuming that we can model this as a binomial distribution and so on, then we should be able to reach meaningful p-values. But what happens if we do not trust our p-values? So what we did was simulate a lot of users doing this with a known bias for one of the interfaces. And by varying the bias, we can see what the p-values that come out are. And we know that these are 100% random users using a Gaussian centered around 5 to do their ratings. And they have a little deviation to one side according to this number here. So this is a way of graphically looking if our methodology is sane. So we conclude that the methodology works as long as we either use at least some 8 ratings per person. That's the point where we find no false negatives
How many ratings do you need in order to have a valid p-value?
It depends on two things: on the users and the number of the number of ratings. So they're correlated. The more users you have, the less ratings you need.
And the final result should be more than?
And what varies there is the sensibility. So if you get a p-value of 0 or very, very close to 0, you can trust it quite a lot if you're using at least 8 evaluations for 20 users. And it will be capable of sensing with high fidelity anything that is more than, say, 0.75 preference out of 10 stars. And conversely, if you have a lot of users and only 4 ratings, it will be able to have about the same sensibility, and you will also be able to trust it quite a lot. So if we don't have hard data, but we have really good intuitions about where the numbers are.
What kind of users did the test?
Computer scientists doing a master's on game design, but they had not used our specific tool before.
They were a little related with.
Yes, but they're not completely independent.
And do you think with other kinds of
We should eventually both use more users and less experienced users. But otherwise, we would not have been able to get away with giving them 5 minutes of talk about the tool and then having them do a course in 1 hour. We would need at least 1 hour to explain how it works. So, thank you very much.